There are few things more gripping than a story of survival against all odds. And survival situations don't get much more extreme than being left helpless and alone in absolute darkness at the bottom of the sea. After experiencing a terrifying dive gone wrong, Chris Lemon survived for an unbelievable 30 minutes without oxygen. But how? Let's take a deep dive and explore how one man survived the unsurvivable. Before we jump into the North Sea's depths with Chris Lemons, let's emphasize just how important oxygen is for survival. Every time you breathe in, your lungs gather oxygen to supply to your red blood cells. Your red blood cells then take that oxygen and carry it throughout your body, distributing it into your organs and muscles along the way. Oxygen is essential in helping our cells convert glucose into energy. The energy produced allows your heart to beat, your muscles to move, and fuels every process your body needs to survive. Of course, this means our bodies can't function without it. Without oxygen, our bodies shut down, using the minimal oxygen left in the bloodstream to run the most vital operations for as long as possible. As the oxygen depletes, neglected cells begin to die off, eventually leading to unconsciousness and death. Considering how vital it is for every part of our bodies, it makes sense that the average person can only live a few minutes without oxygen. Thanks to science, we can carry handy tanks of vital oxygen around, allowing us to spend time in places where breathing would usually be impossible. This allows for incredible procedures like saturation diving, the occupation of deep-sea survivor Chris Lemons, which takes place in the harshest of conditions. Saturation diving is a form of deep ocean diving used to construct and repair undersea equipment. Divers live in a pressurized chamber for extended periods before they dive, which mimics the pressure divers will experience in the depths, allowing their bodies to acclimatize. When it's time to work, the divers climb inside a smaller, equally pressurized chamber called a bell. The bell descends deep into the ocean at the work site. After underwater work is completed, divers return to the bell, which brings them back to the pressurized chamber on ship. Once the period of working, which usually lasts several weeks, is over, they are slowly and carefully decompressed over several days. With this kind of deep-sea work, there are naturally many hazards for the divers. One of the biggest is maintaining air supply through the diver's umbilical cord, which is actually pretty similar to its namesake's fleshy tube between mother and baby. This long, sturdy cord attaches the diver to the diving bell, supplying heat, oxygen, contact with the ship, and any other necessities for survival at such depths. The umbilical is literally the diver's lifeline, making any faulty equipment or damage to the line incredibly hazardous. Decompression sickness, or the bends, is yet another risk divers face, and occurs when divers return to lower pressure levels, usually near the surface, too quickly. During a rapid change in pressure, dissolved nitrogen in the blood attempts to exit the body extremely quickly. And like a Target on Black Friday, the mob breaks its way through by any means possible. This can result in bubbles forming in the blood, causing a myriad of agonizing problems. This typically involves rashes, headaches, joint pain, and can even cause paralysis and death in extreme situations. Saturation diving is designed to lower a diver's risk of developing the bends by ensuring decompression occurs as slowly as possible. Knowing all the dangers didn't stop Chris Lemons heading out for a dive on September 8, 2012. In fact, like most saturation divers, he loved his job. For him, the unique experiences on offer far outweighed the risks. Chris had been living in the pressurized saturation system on the ship Topaz for a couple weeks, accompanied by Dave Uasa, Chris's partner during the dive, and Duncan Alcock, who would remain inside the bell to oversee the procedure. Up on the ship, a large team were responsible for the countless details necessary for a safe dive. Everything seemed fine leading up to the dive. Weather conditions were a little rough, but still safe for diving. Duncan, Dave, and Chris boarded the bell and descended into the depths of the North Sea. The divers had been working for a while when the weather suddenly shifted for the worse. The boat's navigational systems failed, meaning it couldn't hold its position for the divers. The massive ship started rapidly drifting away, and the divers were told to return to the bell as quickly as possible. To return to the bell, Chris and Dave needed to climb the structure they'd been working on. On this climb, disaster struck. While Dave was carried off with the ship, Chris's umbilical cord got snagged on a part of the manifold, trapping him. Before he knew it, the pulling force of the 8,000-ton boat snapped his umbilical, and he dropped to the sea floor in pitch blackness. While everyone above Chris desperately tried to return to him, Chris made use of his 2 air bottles, known as bailouts. Altogether, they only contained 5 minutes of air. Chris was at the bottom of the North Sea with no light or heat, no contact with the ship, and a rapidly dwindling air supply. Thinking quickly in the impenetrable darkness, Chris located the manifold and climbed to the top. He knew that in this position, rescue would be most likely, but by the time he was at the top, his air supply was almost gone. Chris had no choice but to lay there and await rescue, 300 feet underwater, with his breathing becoming harder by the second. Chris thought about his fiancée and family dealing with his death, and in his calm state of sadness, he eventually lost consciousness. Up at the surface, after frantically restarting the boat's computers, the navigational system came back online, allowing the boat to return to Chris. When the ship was finally in position, 30 minutes later, Dave hastily dragged Chris back to the Belle. Once inside the Belle, Duncan set to work on reviving Chris with CPR. Half an hour after Chris ran out of oxygen, by some miracle, he reanimated with a deep breath. When one of the already saturated medics on the ship finally tended Chris, he was shocked to find that, despite being exhausted and blue from the cold, he was fine. He'd suffered no brain damage, nor any other issues associated with his lack of oxygen. But how was this possible? There are many factors that could have led to Chris's miraculous survival. One of these might have been Chris's body and brain cooling in the water of the North Sea, which was likely below 37 degrees Fahrenheit. After his umbilical snapped, losing his source of warmth, Chris's brain would have rapidly dropped in temperature. A person's metabolic rate, or how much energy their body uses, decreases at lower temperatures. Because of this, a cooled down brain can survive significantly longer without oxygen. According to Mike Tipton, head of the Extreme Environments Laboratory at Portsmouth University, if the brain drops to 68 degrees Fahrenheit, a person can survive for up to an hour without oxygen. Chris has since noted that he did not feel any cold or pain, indicating that non-essential parts of his body had been numbed by the intense cold early on. This helped him remain calm and allowed his body to prioritize vital functions. A reaction known as the diver's reflex may also have helped Chris. The diver's reflex is a survival response built into our bodies and is usually triggered by diving into cold water. The reflex slows down a person's heart rate, allowing their respiration system to work on battery saver mode, conserving energy and lengthening survival time. The cold water of the North Sea may have gotten into the inner lining of Chris's helmet and suit, making direct contact with his skin, activating the reflex. Chris's saturation diver training likely played a role in his survival too. Due to saturation divers' regular exposure to extreme environments, like the bottom of the North Sea, it's speculated that their blood cells might be altered in the process. During saturation dives, red blood cell production is significantly reduced in divers, which means that oxygen is transported more slowly. This would ultimately lengthen the amount of time a diver can survive on minimal oxygen, or even without oxygen. It doesn't account for a whole 30 minutes, but it likely played a role in Chris's survival. One of the most important factors allowing Chris's survival were his emergency bailouts. With higher oxygen content than regular air, the bailouts saturated Chris's tissues with oxygen. When the bottles ran out, his body made use of the surplus oxygen for vital roles like keeping the cells of the brain alive. The few extra minutes of life afforded by this surplus was, according to Chris, one of the deciding factors of his fate. But all these factors would have been for nothing if it weren't for Chris's clear-cut actions to facilitate his rescue. Rather than panicking, he knew he needed to get to the easiest spot for his team to find him. He didn't try to frantically reach the surface when he realized he wouldn't make it. If he had, he would have died from the exertion, lack of oxygen, and rapid change of pressure. Chris stayed at the top of the manifold, and on top of all that, he remained calm. As any diver knows, staying calm when oxygen is involved is absolutely necessary. A person at rest on average breathes a little more than 1/5 of a liter of oxygen every minute. A person that is stressed can breathe as many as 4 liters per minute. Chris's calm breathing extended his air supply and slowed his body's usage of oxygen. To this day, there's no exact answer for how Chris survived. It was probably a combination of all these factors that helped his body keep going. but in extreme life or death situations, it's not uncommon for people to exhibit superhuman abilities to ensure survival. Indeed, Chris isn't the only person to surpass oxygen limits like this. Guinness World Record holder for underwater breath holding, Alex Segura Vendrell, holds the title at 24 minutes and 3 seconds. Vendrell breathes pure oxygen before his attempts, on top of being a trained free diver. Evidently, Vendrell utilizes some of the factors that help lemons survive, like oxygen saturation in the blood and training. Only Vendrell is crazy enough to do it by choice. Another accidental but extraordinary underwater survival story is that of Michelle Funk. At the age of 2, Michelle was submerged in freezing water for 66 minutes after falling into an icy creek. Amazingly, she was resuscitated with no permanent damage to her brain or body at a local hospital. Experts believe the icy water shocked Michelle's system, working in much the same way as with Chris. Her brain cooled and non-essential body parts shut off. The diver's reflex also likely contributed to her survival, slowing her heart rate almost to a stop. Children's bodies cool rapidly, and doctors estimated that Michelle quickly fell into hypothermia, ultimately allowing her to survive. A final fascinating example are Indonesian diving fishermen, the Bajau, who have evolved to survive underwater. Due to their millennia-old tradition of underwater hunting, the Bajau have developed a gene that allows their spleens to grow 50% larger than normal. This gives them additional oxygenated red blood cells, allowing longer dive times. An average Bajau spends 60% of their work period, which usually lasts 8 hours, hunting underwater, up to 13 minutes at a time. This, alongside the other fascinating cases I've mentioned, makes it clear that the body is capable of some incredible things, maybe more than we'll ever fully understand. Chris Lemon knows this better than anyone, and for these incredible gifts, he and his family remain extremely grateful. Knowing Chris's story, what would you attribute his survival to? Are you as amazed as I am by what the human body can do? Let me know your thoughts in the comment section below. Thanks for watching.